Welcome everybody, welcome to Chapter 5, Inflation, its causes, effects and social costs. This is the structure of this chapter. As you can see, like a lot of different topics are covered, somewhat longer chapter, and therefore I will also split this chapter in several videos. Let's start with some introductory remarks. Inflation is defined as an increase of the overall price level. This is very important. In case that only the price of one good, let's say the price of butter or the price of bread increases, this will not be labeled as inflation. Therefore, we are also using a relatively broad basket of goods when it comes to the consumer price index. So we have to think about the overall increase in goods prices. This chapter once more follows the classical approach, the classical theory, so that we have a focus on the long run effects and therefore the goods prices are flexible. In case that we want to focus on the short run, we have to look into chapter 10, where we assume that many prices are sticky in the short run. In order to understand inflation, we have to understand the relationship between money and inflation. So also money supply will play an important role in this chapter. In the beginning, the following relationship is introduced, like money times the velocity of money has to be equal to the price times the number of transactions. I would like to come up with a very interesting example, and it stems from the movie Lolek and Bolek. Lolek and Bolek on the campsite. I'll use this example to highlight the meaning behind this kind of relationship here. So what's going on this campsite? Lolek and Bolek, they make holidays on a campsite. They are thirsty and they both walk, because they don't have a car, over to the next supermarket, which is about 5 kilometers away. They buy a box of beer with tea equal to 20 cans. On their way back, Lolek becomes a little bit thirsty. Lolek has still M is equal to 4 euros in his pockets, and Lolek asks Bolek whether he can buy a beer from him. Bolek agrees and fixes the price to P is equal to 2 euros per can. Lolek drinks the first beer, but you can't stand on one leg. Like as a very famous German saying says, auf einem Bein kann man nicht stehen. After Lolek has finished his first beer, he is still thirsty and decides to buy a second beer. After a few minutes, it is Bolek who becomes thirsty. And since Bolek now has a 4 euro in his pockets, Bolek decides to buy 2 beers from Lolek. A few hours later, they are back on the campsite. The box of beer is empty and Lolek and Bolek are both drunk. The big question now is, how can money supply of 4 euros finance transactions which have a value of price times transactions, 2 times the 20 cans? The transactions, they have a value of 40 euros. So how can money supply of 4 euros finance transactions which has a value of 40 euros? To phrase it a little bit different, how often has money changed the hands? Or in other words, how large is the velocity of money? Let's check. We have this relationship here, price times transaction is equal to money times the velocity. Or when we skip the words and just look at the symbols, M times V has to be equal to P times T. When it comes to LOLEC and BOLEC, it is the case that we have isolate V on one hand side of the equation. So we are isolating V on one hand side of the equation by dividing by money supply. And hence we get to this relationship here. The velocity is equal to the value of the transactions, price times transactions, divided by money supply. So in our example, it was the case that the value of transactions was equal to 40 euros, money supply was equal to 4 euros, and therefore we are able to compute the remaining variable, the velocity of money. It seems to be the case that the money changed 10 times the hand between OLEC and BOLEC. The quantity equation M times V is equal to P times T is an identity. It always has to hold. In case that one variable changes, one or more of the other variables also have to change. Like in the LOLEC and BOLEC example, when, for example, money supply increases, most likely it would be the case that the velocity of money would decrease. This is my best guess when it comes to this example. But of course, we don't want to focus on this microeconomic example only, LOLEC and BOLEC, but we would like to use this relationship in the end to explain inflation. And therefore, we are adjusting this equation a little bit. Instead of putting the number of transactions here on the right-hand side, we are inserting the output, like the GDP level of our economy on the right-hand side. And therefore, this equation becomes money supply times velocity is equal to price times the GDP level. This is a central equation which we are going to use in the next few steps. But in the first step, I would like to focus on money demand. When it comes to money demand, I would like to talk about the real balance of money. The real balance of money is given by the relationship M over P. It measures the purchasing power of the stock of money. When it comes to, once more, the LOLEC and BOLEC example, there M over P was equal to like 4 euros money supply divided by the price level 2 euros per beer. So M over P is equal to like 2 beers. Like the current money balance is large enough to finance 2 beers. So here we are assuming that real money demand over price is equal to K times Y. So money demand depends on the GDP level in a positive way. In case that the GDP level increases, then money demand increases. Frequently, students ask, hey, what is the relationship between money demand on the one hand side and this parameter K and the marginal propensity to consume, like an element which is in the consumption function of the private households? And I would highlight this relationship by also coming up with another numerical example. In the subsequent slides, I would like to talk about the difference, but also about the relationship between the marginal propensity to consume and money demand. Let's assume that one household has a monthly income of 2,000 euros and the marginal propensity to consume is C1 is equal to 0.8. So the consumption function is given by consumption is equal to marginal propensity to consume times the GDP level. So here we are assuming that the autonomous component of consumption is 0, and we also are assuming implicitly that the taxes are equal to 0. So then we know that the household is spending 1,000 euros per month. Let's also assume that the salary is paid on a weekly basis, and therefore the household is walking once a week to the ATM. Money demand is equal to like 400 euros, like 1,600 euros. This is the spending per month. And since the household is walking to the ATM 4 times a month, money demand is only 400 euros. Hence, we can plug in what we know. From this numerical example, we know how large money demand is. We know how large income is. And therefore, we can compute in the end this parameter k. So parameter k can be determined in this example. And it is the case that when we solve this relationship for k, then the parameter k will take the value of 0.2. So there is indeed a relationship between the marginal propensity to consume and money demand, but there is also like a difference. This is once more mentioned on the next slide. There is a relationship between consumption and money demand, but the most important insight from this numerical example should be that the payment habits influence money demand. So it really depends on whether salary is paid on a weekly basis or a monthly basis, whether the household is going to the ATM every week or only once a month. So the payment habits influence money demand. And one assumption of the classical theory is that the payment habits are pretty stable in the short run. Payment habits can change over time, but payment habits are pretty stable in the short run. And one consequence is then that money demand is also pretty stable in the short run. Let's try to once more combine the relationship which we were using so far, like the relationship between money demand and our quantity equation. So let's start with equation number 11, where on the left-hand side we have real money supply, and on the right-hand side we have real money demand. In case that we put k on the left-hand side of the equation, and p on the right-hand side of the equation, we get to equation 12. Like k on the left-hand side pops up in the denominator of this fraction, and p on the right-hand side pops up here in the product p times y. This looks a little bit like this quantity equation. So the quantity equation was given as m times v is equal to p times y. So it seems to be the case that there is a relationship between this money demand parameter k and the velocity of money. The relationship is that the velocity is equal to 1 over k, and hence the velocity is influenced by money demand and the payment habits of the economy. In case that the people want to hold only little amount of money, in case that k is relatively small, then money will change the hands frequently, the velocity will be relatively large. Here I would also like to relate this relationship to the subchapter 5.6, where we talk about hyperinflation. In a situation of hyperinflation, it is the case that the purchasing power of money deteriorates very rapidly. Like already in a few minutes or a few hours, prices can increase, and therefore people try to hold as little money as possible. So, like in a hyperinflation, it is the case that k is relatively small and k is decreasing over time. And this implies that the money will change the hands more frequently, like the velocity is relatively large and the velocity will increase. So times of hyperinflation, they are very special because in times of hyperinflation, the velocity is not constant. In the next few slides, I would like to use the quantity equation, and based on this quantity equation, I would like to derive the so-called quantity theory. Let's start. The quantity equation is once more given by equation 14. And when we write the quantity equation in percentage change form, then we get the percentage change in money supply plus the percentage change in the velocity has to be equal to the percentage change in the goods prices plus the percentage change in GDP. In case that the velocity is constant, so a central assumption of the quantity theory is that the velocity is constant, then we put a bar above this variable y. In case that the velocity is constant, the velocity does not change, and therefore the change in the velocity is equal to 0. When we now solve equation 17 for the inflation rate, then we get the following relationship. So we have to put this delta y in percent on the other hand side of the equation. It will pop up with a negative sign. So here we have isolated the inflation rate on the left hand side of the equation. So the inflation rate is equal to the growth rate of money supply minus the change in GDP. The growth rate of GDP is assumed to be given by the change in the labor force and the change in capital. So this is one assumption of the classical theory. In the classical theory, and the quantity theory is a classical theory, we assume that the change in labor force and the change in capital, they drive the growth rate of GDP. Let's assume that the growth rate of output is a constant. Let's assume that this delta y in percent is equal to a constant, is equal to alpha. When we insert now this alpha instead of this expression, we get to equation number 19. So the inflation rate is equal to minus alpha plus the change in money supply. So the inflation rate changes on a one-on-one basis with changes with the growth rate in money supply. So this implies the quantity theory of money states that the central bank, which controls money supply, has the ultimate control over the rate of inflation. If the central bank keeps the growth rate of money supply stable, then also the inflation rate will be stable. Let's try to analyze this relationship in form of some empirical evidence. Like in the first graph, you can see on the horizontal axis the growth rate in money supply, and on the vertical axis the inflation rate in percent. This empirical evidence is related to the US. So we are looking at the US economy, and each dot indicates the growth rate of money supply and the inflation rate within one decade. So we have a very long run empirical evidence here. And it is indeed the case that there is a positive relationship in the growth rate of money supply and the inflation rate. In case that there is a high growth rate of money supply, it's also the case that in this time period, the inflation rate is pretty high. For example, here we find the 1970s and the 1980s, like with the oil price shock, and very high inflation rates. So there is indeed a positive relationship between growth rate of money supply and the inflation rate. But I would like to use this graph to also focus on a different detail of this diagram. The detail of this diagram is that when we run a regression through these dots, it is the case that the y-intercept is negative. Let's include a regression line here. So we are including one regression line. And then let's focus here on the intersection of the regression line with the vertical axis. The intersection occurs at the value of about -5. So minus alpha is equal to -5. And this is completely like in line with our equation number 19 with the quantity theory, where this negative constant also plays an important role. It seems to be the case that during this time period, the growth rate of GDP was like positive, and therefore this curve intersects with the vertical axis in the negative range. Here in this graph, we only have empirical evidence for the US. Let's have a look at the empirical evidence for a cross-section of countries. So the big difference between these two diagrams is that here we are looking at a time series of US data, and in the next graph we are looking at a cross-section of different countries. And also here it seems to be the case that we have a positive relationship between the growth rate in money supply and the inflation rate, like a positive relationship. And also here it seems to be the case that when you would include a regression line in this diagram, then the intercept with the vertical axis would occur in the negative range. So also here this theory is confirmed by the empirical evidence of a cross-section. There is indeed a positive relationship, and the intersection of a regression line with the vertical axis, the so-called y-intercept, is in the negative range. I would like to stop here so that you have some time to go back to the textbook and read, so that you have some time to digest this kind of stuff. Thank you very much. Have a nice day, and we'll meet later on. Thank you.